in forensics engineering, it is oftentimes very, very valuable to be able to see inside of something. Oftentimes before you disassemble something, it's very valuable to know what state the object was in before you started to disassemble or cut it. I also say one of my mantras is anything with a spring. Invariably, when you take something apart with the spring inside of it, it goes boing and goes flying across the room. You can never really figure out exactly how the components were put inside of there in the first place. Also, it gives you the ability to make shortcuts where you may need to slice an object numerous times to find a defect. This allows you to look through the entire object very, very quickly without destroying the evidence. And that way we can go through and slice directly to that location to look at it through more traditional microscopy.
We were looking at a millographic mount, so a cross-section through a blade, a turbine blade. So what we can do with the CT scanner is actually CT scan the mounted blade and actually look for features that are now inside the mount without breaking it out of the mount, which is a very useful tool, especially if you're looking for voids or any type of anomalies. Plus, what that does, it also allows you to orient the way the sample is in the mount, because sometimes when you're looking at a turbine blade or some kind of complex structure, you're only looking at the polished surface, so you don't know where that is in the polished surface. So that's a very valuable tool to kind of orient yourself of what are we actually looking at. And we've done that on several cases where it gives the client an idea of, okay, so here's the object inside the mount and we're looking at this face. And I think that's a very demonstrative type of illustration. What you can also do is if you're looking at a piece inside of the mount and you want to get to a certain feature. And oftentimes in these mounts, you can't see where that feature is because it's in a opaque mount.
So it would be much like if we were in a metallurgical lab like we are here. We'll take an object, we'll cut it, we'll polish it, and we'll look at it. And that's one plane, it's one slice of something. I have the same thing in my CT scanner, except for it's going to be, one, not destructive. I don't have to cut it up to do it. And also two, when I'm looking at the density variations across that.
You can actually measure where that is from the plane of polish, and then remove that material, and then now you have a one-to-one match of what the CT scan is showing and your polished surface. So again, that's another tool where the CT scan, you couldn't do it without breaking it out of the mount or doing a lot more work.